Hey everyone, welcome back. It's me, the part-time economist, and in today's video, I'm going to show you a package in the R programming language that can make it super easy, super simple, and super quick to validate your data. But before we get into the package itself, I do want to talk very briefly about the importance of validating your data. Now, when we're looking at data, we're more often than not doing this to draw a conclusion, to make a prediction, right? And it's important that our data is accurate. Now, let's suppose, for example, that we are talking about the miles per gallon of a new vehicle, right? And you know, on the number pad, the number 3 is right below the number 6. So let's suppose someone messes up and instead of typing 33, they type 36, right? If we're working with something like the mean, that's a significant outlier, right? And 66 can really throw off our data set if the mean of all the other cars is something like 25, right? So what we want to do when we're validating data, we want to come up with essentially a range of what would be considered acceptable values. Now, obviously, this is going to depend on the context, right? If we're talking about miles per gallon, maybe it's somewhere between 10 and 40, right? If we're talking about the number of cylinders in a car, maybe it can take on values of 4, 6, and 8, right? So with that being said, let me show you how to validate your data in R. Now, the first thing we're going to do, we are going to install the validate package, and then we're going to go ahead and pull it into our workspace. Now, the data set that I'm working with is empty cars. So let's just go ahead and let's take a look at what that data set is. So this data set is essentially a bunch of different vehicles. It has their miles per gallon, how many cylinders they have, their horsepower, just random things about the vehicles. So again, let's suppose we want to do a little bit of validation here. So let's suppose, for example, that the miles per gallon should be greater than 0, right? If the miles per gallon is not greater than 0, then it's not really a vehicle, right? Because it's not transforming fuel into distance. So that needs to be greater than 0. Now, what's the upper limit? Maybe we don't know, right? Maybe we don't want to put a bound on that. Now, cylinders is a categorical, right? It's going to be 4, it's going to be 6, it's going to be 8, right? So we need to do this a little bit differently. We're going to do cylinders, we're going to do percent in percent, and then we are going to pass in a vector of the specific values that it can take on, right? Horsepower, again, greater than 0. Now weight is where we're going to do a kind of a bounded condition here, right? So weight, it's got to be greater than equal to 0, and it's got to be less than 6, right? Again, I'm just making these values up. I'm not an expert when it comes to vehicles, but if you are working with a different data set, right? Maybe your length on a specific measurement could be between 1 and 5, and anything greater than 5 is possibly an error, right? So what we're going to do, we're essentially going to create this list of all the different rules. Now, after we create that list of rules, we are going to actually apply it to the data set. And the way that we do that is by using the confront command. I know it sounds a little bit, hostile and stuff like that, but that's what the command is called. So we're going to create a variable, and I'm calling it out. You could call it whatever. You could call it results. It doesn't matter. You're going to do confront. You're going to pass in the name of the data set, and then you're going to pass in these rules that you created. Now, what's going to happen is it is going to go through, it's going to do the analysis, and we're going to summarize that. Now, what you'll notice is that for each of these, it tells us how many total items we had, how many pass, how many fail. It's going to tell us a bunch of things, right? Now, the important thing for our purposes is that each of these observations pass, right? So every single observation we have in this data set aligns with these rules. So let's suppose that we want to throw an error, right? I just want to show you how this would work. So what I'm going to do is I'm going to change one of the cars. I'm going to make it have 9 cylinders. So if we go back through this data set, we can see that we changed the Mazda RX-4 to have 9 cylinders, which obviously that's not the case, right? It doesn't have 9 cylinders. So watch what happens when we run this confrontation again. It's going to go through and it's going to say, look, you had these 32 observations, but with respect to your second rule, right? And it's going to tell us what that rule was. With respect to your second rule, you had one observation that failed, right? So that's really cool. That's a really quick way of checking our data, making sure that it meets those bounds that we've specified, right? And obviously, could there be a car with 9 cylinders? Maybe. I don't know, right? But what this does is it gives us cause to look closer and say, was this really accurate, or was this a data entry error? If we go back and we say, look, this car, it was a prototype, it really did have 9 cylinders, fine. We can run the data set, right? If we go back and we say, look, this car obviously doesn't have 9 cylinders, then we can either remove it from the data set, we can correct the value, whatever the case may be. Now, I do want to point out that I just showed you one very simple example of what this can do. If you look at the documentation for this package, it has a ton of other functions that you can use for your specific purposes, but obviously I can't cover all of it in today's video. This quick tutorial should get you covered with most of the basics. So with that being said, thanks so much for watching. I hope you enjoyed the video, and I hope you enjoy the rest of your day.